All right, on page 706 today, gonna work with and talk about central angles and arcs. And we'll define a central angle. Central angle of a circle has its vertex on the center and its sides form an arc. So, central angle of a circle has its vertex on the center and its sides form an arc. So, a diagram of that or a picture of that, you got a circle, center, call it point B. Now, if we just draw an angle inside of this circle, the vertex of this angle is point B. Points A and C form arc AC. So, angle B is a central angle. Arc AC corresponds to angle B. All right, hopefully everybody can see that. We've got this angle, angle B. Its vertex is on the center of the circle. All right, side BA and side BC form this angle. And where the sides of this angle intercept the circle forms an arc. So this arc right here is called the corresponding arc. So our rule that is associated with central angles is that the sum of the central angles of a circle is 360. So if we draw another circle here, and I'm going to put in 1, 2, 3 other segments. What I just formed here was angle 1, angle 2, angle 3, and angle 4. And our rule says that the sum of the angles, the sum of the central angles of a circle is 360. What that means is that angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360 degrees. And we're going to use that rule today to find central angle measures inside of a circle. Because once we know these central angle measures, then we know the arc measure of its corresponding arc. Okay? So look at example 1, and you can draw that diagram if you like. It's like there's 3 central angles in there. And we got G, J, H. The center of this circle looks to be F. Calling this 90 degrees. That doesn't really look like a 90-degree angle. So let's call this angle 100. And we'll call this one 120. And we're going to put the variable x right here for degrees. And we have to find x. All right, so just like when you were finding missing angle measures inside of a triangle, the sum of the angles of a triangle is always 180. The sum of these angles, the sum of the central angles of a circle is 360. So we can say that x is equal to, it's going to be 360 minus the 100-degree angle minus the 120 angle. And that 360 minus 220, 140 degrees. All right, so this third angle inside this triangle is 140 degrees. Keep in mind when you get the symbol for a right angle inside of a triangle or inside of a circle. All right, if we're given this picture, the symbol in here means 90 degrees, so don't forget to subtract that 90 degrees from your 360. So again, x in this case would be equal to 360 minus 90 minus 150 and it's 120 degrees. All right, so angle x right here would be 120 degrees. All good with that? All right. Pretty straightforward. On the bottom of page 706, an arc is a portion of a circle. defined by its endpoints. A central angle separates the circle into two arcs, with measures related to the measures of the central angle. The measure of an arc is congruent to the measure of its central angle. The measure of an arc is congruent to the measure of its central angle. So if we go back to this kind of basic picture we've been looking at, and if we divide this up, and let's say that we'll label these A, B, C. If we put some central angles in here, if we make this top central angle 100 degrees, and then the angle next to it 110 degrees, we can find the third angle, right? So once we find this third angle, so we got 360 minus 210 is 150. 150 degrees. So those are our three central angles and their measure. Now, this arc AB up here, here's your arc AB. Its central angle is 100 degrees. Agreed? That angle formed arc AB. So since that angle formed arc AB, then arc AB is 100 degrees as well. If we look at arc BC, arc BC was formed by a central angle that measured 110 degrees. So the measure of arc BC is also 110 degrees. And then because that's true, then arc AC which was formed by a central angle that had a measure of 150 degrees, will measure 150 degrees. All right, so your notation for that could be arc AB is equal to 100. Arc BC is equal to 110. And arc AC is equal to 150. Now, a minor arc is less than 180 degrees and named by its endpoints. A minor arc is less than 180 degrees and named by its endpoints. So the three arcs that we named them and we listed their measure. Those were three minor arcs. They were all less than 180 degrees. So when you're naming a minor arc, you name it by its endpoints only. This first arc AB, we started at point A, we went to point B, we named it AB. All right, arc BC, it started at point B, we went around the circle directly to point C, we called it arc BC. And then arc AC, we started at point A, we went around the circle. If maybe you're tracing your pencil or you're just looking at your paper, you're tracking it with your eyes, you're going A directly to C, shortest route possible from A to C. We call that arc AC. Minor arc. These are all minor arcs. A major arc. All right, this minor arc, this is important. And so is this. Major arc is greater than 180 and named by 3 points. So when you're naming a minor arc, you use 2 points, the endpoints. When you're naming a major arc, you're using 3 points. Here's what I mean. So if we draw another circle here, and we can actually use the same, let's try to use basically the same point A, point B, and point C down here. Try to use the same picture so that you can see the difference between these minor and major arcs. In the top example, we were talking about minor arcs. Now, there's a lot more arcs in this picture than those 3 minor arcs. We've got an arc that can start at A, it can go through B, and it can end up at C. See it? If we start here at A, and we start going around this circle, and we go to B, and we don't stop at B, we keep going, and we go all the way down here to point C. That's called a major arc. It's greater than 180 degrees because if we took this radius here and we extended it, that would give us a half of a circle, and the measure of a half of a circle is 180 degrees. We're past 180. What we're really at is if this is 100 and this angle is 110, then the measure, all right, you could note this, the measure of arc, now we call it ABC. With the first point and the last point of the description being the endpoints of the arc, but point B, the middle point, the middle letter in the description, is the point you went through to get from A to C. All right, so the measure of arc ABC is going to be the sum of 100 and 110, which is 210. if we put this 150-degree measure back in here, let's look at this other arc. We've got an arc here that can start at B. It can go clockwise through C and end all the way up here at point A. That's another major arc. So we got the measure of arc. Now we're starting at B, we're going through C, and we're ending at A. So that's arc BCA. Arc BCA, since it's made up of two central angles, is the sum of those two central angles. So the 150 plus the 110 is 260. So minor arcs, you start at one endpoint, you go directly to the next endpoint. You don't go through any points in between. They're less than 180. Major arcs, when you're going more than halfway around the circle, you have to use 3 letters. The middle letter being the point you went through to get to the other endpoint. Okay? So there's one more major arc. Well, we can have a few more, but the measure of arc, if we start at C and we go around the outside here, we go through point A and we end at point B. That's another major arc. That's arc CAB. The measure of arc CAB would be the sum of the two central angles that form the arc. So 150 plus 100 is 250 degrees. All right, so everybody all right with that? Central angles, minor arcs, major arcs. All right, then your practice for today. Page 710. 1 through 5. And then 12 through 23.